So this one here is asking us to find the current IX. So they already defined the current for us here. How do we do that? So let's see what we have. So we have a current source that's pumping out 10 amps, and then we have 1, 2, 3, 4, 5, 6, 7 resistors. And we want to know just this one branch. So just this, okay? But what's going to happen is this 10 amps that's going to come up through here. We still have 10 amps at this point. Amps, not ants. Anyway, so we're going to pass through here with 10 amps. We're going to get here. We're going to see we have two options. We'll travel this way. We don't know how much voltage or current we have, but we'll hit right here. We'll split off again. Don't know how much we have here. Split off again. And then we're going to do this. So we're going to split off and meet back up all over again. So our 10 amps are going to break off and they're going to come back to give us 10. So the easiest way to go about doing this would be to, any suggestions? I mostly just want to take a sip of water so you guys can type.
Would we want to make our circuit be in parallel so we can do current division?
That is an excellent idea. Let's give that a shot. So let's see if we do that to do a current division. We need stuff to be in parallel. Not necessarily everything, but we need a parallel. Since we only care about this one branch here, what we need to do is get something in parallel with this branch. And looking at this, looking at the side, we've got a little bit of massaging to do before we can get it to exactly parallel. But those steps are pretty easy, they're pretty straightforward. So let's go ahead and give that a shot. So let's say that these three here are in series 1. So our series 1 will be 3 plus 2 plus 1, which will give us 6 ohms. And I promise you guys, the drawing will cease within about 1 or 2 more SIs. Okay, 6, 2, 3, and then 4. And then, why not 5? Maybe a 10. Okay, so now let's look at this entire circuit. We said that 10 amps is going to break off down here, and some is going to go that way. And then some go down that way, that way, that way, like that. Well, do we really care about what that current is, what that current is, and what that current is? Not really. All we care about is our boy 4 right here. So what we're going to do is we're going to say, okay, we'll take these 3 and we're going to combine them down, and we'll make this circuit. For, and I'm going to call this one R parallel 1. Okay. All right, and then we also have 5 up here. We have 10 amps right there. Okay, so all we did was we took that R parallel, we're going to break it up, and now we have our parallel branches. But we need to find R parallel first. So how do we do that? Well, we can do a couple things. Good Lord, what is happening? Okay. All right. So let's find out what that is equal to. So if I do r parallel 1 is equal to 1 over 1 over 3 plus 1 over 1 over 2 plus 1 over 6 3 plus 1 divided by 2 plus 1. All right. And doing some quick math, that'll give us 1 ohm. Okay, so R parallel 1 is equal to 1 ohm. All right, so now what we can say is that's R parallel 1, but to find out what the current is doing, that 10 amps, it's still going to break off this way and that way, but this is IX here. So we need to find this R parallel. I'll call that R parallel 2. And fortunately, it's only 2, so it'll be 4 times 1 over 4 plus 1, which 4 over 5 is 0.8. So now we can say to find I of x, that will be equal to 0.8 over 4 times 10, which should give us 2 amps for I of x. Okay? So there we are. And I've got a minute left, so I'm going to show you another way you could do it, because you're all trapped here and I'm leading this meeting. All right, so we know that R parallel is 0.8. So R parallel 2 is 0.8. And this was 10 amps. So if we did this, this was 5, and then this was 0.8. This said R parallel 2 right there. And if we set up here that all of these are in parallel, so if I found the voltage across here, I'll call it V of x just for consistency, with I of x going through it. So if I did V of x is equal to I of x times that R parallel 2, that voltage will give us I of x was 2 amps times R parallel 2, which we said was 0.8. 2 times 0.8 will give us 1.6 volts. So we know that here V of x is equal to 1.6 volts. Well, if all of this stuff is in parallel with each other, then all of these have 1.6 volts across them. So now you can really find any value you want just by doing I is equal to 1.6 over the resistance. This is for any current. And we're not done yet either. There's still one more thing you can do. So if you didn't want to find the voltage value, you can just say that 0.85 and then 10 amps is just equal to that circuit. They're the same circuit, they're interchangeable. Find I of N, so just any current you want. It's just 0.8 divided by that resistance value times I of S, which was 10. So there's a lot of ways you can solve this, but I just wanted to go through every possible way that I could think of. But does anyone have any questions about this last problem? All right, I'm hearing none. So thank you very much for joining today, and I will see you all next time.